Introduction to Network Intelligence. Welcome to the channel. Please consider subscribing. I produce videos daily covering various cloud topics with focus on networking. Please subscribe and hit the bell icon to get notified. Today we're taking a detailed look at Google Cloud's Network Intelligence Center. As organizations migrate more workloads to the cloud, the networks that support them grow exponentially in scale and complexity. Managing this dynamic environment with traditional, reactive methods is inefficient and risky. Network Intelligence Center was created to solve this exact problem. It is not a single product but a powerful, integrated suite of tools. Its fundamental purpose is to provide a single, unified platform for comprehensive network monitoring, verification, and optimization across your entire Google Cloud organization. The core philosophy driving this suite is a crucial shift in network operations. It aims to move teams away from a reactive model, where you scramble to fix problems only after they cause an outage, to a proactive and preventative model. The goal is to give you the foresight to anticipate, diagnose, and resolve issues long before they can impact your applications and users. The 4 pillars of intelligence. Network Intelligence Center achieves its goal through 4 distinct but deeply integrated components, which we refer to as its pillars. Each pillar provides a unique and essential lens through which you can view, analyze, and manage your network. The first is network topology, which serves as your visual command center, providing a live, interactive visualization of your entire network infrastructure. The second pillar is connectivity tests, a powerful diagnostic tool that performs on-demand reachability analysis between any 2 points in your network. Third, we have the performance dashboard, which is focused on real-world operational health, monitoring critical network performance metrics like latency and packet loss across the globe. Finally, Firewall Insights acts as your automated security analyst, helping you understand, optimize, and harden your firewall rules for an improved security posture. Together, these 4 pillars provide a truly holistic understanding of your network's configuration, real-time performance, and overall security posture. Pillar 1. Network topology, the living blueprint. The first pillar, network topology, is your visual map to the cloud. It's crucial to understand that this is not a static diagram you have to draw and maintain manually. It is a live, data-driven visualization that automatically renders a graph of your Google Cloud resources and, importantly, the traffic flowing between them. It can visualize a vast array of entities, including high-level constructs like VPC networks, hybrid connections such as Cloud VPN and Cloud Interconnect, all the way down to individual VMs, Google Kubernetes engine clusters, and various types of load balancers. In any large enterprise environment with multiple peered VPCs, hybrid links, and complex routing, simply understanding how everything is connected is a significant challenge. Network topology solves this by allowing you to instantly see these relationships, making it an indispensable tool for network comprehension. Network topology, interactive analysis. The real power of network topology lies in its interactive analysis capabilities. The view is not static. You can manipulate it to uncover deep insights. You can filter the entire topology to focus on a specific project, a single region, or even resources with a particular network tag. This allows you to quickly zoom in on the parts of the network that are relevant to your current task. Furthermore, you can overlay critical performance metrics directly onto the graph. You can toggle an overlay to show the average throughput in gigabits per second for every connection, instantly highlighting your most utilized links. Another overlay shows latency, helping you identify performance bottlenecks between application tiers. This ability to combine a structural view with real-time performance data is what elevates network topology from a simple diagram to a powerful analytical tool. Network topology, key use cases. These powerful features translate directly into high-value use cases for any cloud engineering team. For network operations, it enables proactive capacity planning. By regularly monitoring traffic throughput on the topology graph, you can identify links that are approaching their limits and scale them up before they become a bottleneck that impacts performance. For DevOps and release engineering, it serves as a pre-deployment validation tool. Before applying a significant network change, you can use the topology to understand the blast radius of that change and identify all potentially affected services. During an active incident, the topology provides an immediate, accurate map of the network's current state, drastically reducing the time it takes to orient responders and begin effective troubleshooting. Pillar 2. Connectivity tests, your network detective. The second pillar, connectivity tests, is your on-demand network detective. It's a powerful diagnostic tool that performs a static analysis of your network configuration to determine reachability between any two endpoints. It's important to stress that this tool does not send actual data packets. Instead, it simulates a packet's journey by performing a comprehensive analysis of the configuration of every single network component that lies on the path. This makes the test instantaneous and non-disruptive. The endpoints you test can be almost anything: VMs, GKE clusters, Cloud SQL instances, load balancer IP addresses, or even on-premises IP addresses that are connected to your VPC via Cloud VPN or Cloud Interconnect. This flexibility makes it a versatile tool for debugging a wide range of connectivity scenarios. Connectivity tests, a deeper look at analysis. When you initiate a test, the service traces the path of a virtual packet from the specified source to the destination. It meticulously checks every single component and configuration along the way. This includes the network settings on the source VM itself, any egress firewall rules, the VPC's routing table, the status of VPC peering connections or VPN tunnels, and finally, any ingress firewall rules on the destination side. The test then returns a clear, unambiguous result: reachable, unreachable, or ambiguous. The true power of the tool is revealed when the result is unreachable. In this case, it doesn't just tell you that it failed, it provides a detailed, step-by-step reason. For example, it will pinpoint the exact firewall rule that is dropping the traffic or state that there is no valid route in the routing table to forward the packet. This eliminates hours of manual, trial and error debugging. Configuring a connectivity test via gcloud. While running tests in the Cloud Console is straightforward, integrating them into automated workflows requires using the command line interface. The gcloud network management connectivity tests create command is the primary way to do this. The command requires several key parameters to define the test. First, you provide a unique name for the test, which serves as its permanent identifier for future reference. The source instance parameter specifies the full, qualified path to the source VM where the test originates. The destination IP address defines the endpoint we are trying to reach. You must also specify the network protocol you wish to test, such as TCP, UDP, or ICMP, using the protocol flag. If you are testing a TCP or UDP connection, you can also specify the destination port to test reachability to a specific service. This command then initiates the comprehensive analysis in the background, analyzing connectivity test results via gcloud. Creating a test is an asynchronous operation. To get the results, you need to use a separate command to fetch the completed analysis report. The gcloud network management connectivity tests describe command, followed by the unique name you assign to your test, retrieves this report. The output is a detailed object, typically in YAML or JSON format, containing the full analysis. Within this output, the most important field to check is the result field, which is located under the reachability details object. This gives you the final verdict of reachable or unreachable. If the test was unreachable, the surrounding fields, particularly traces, will provide a detailed, step-by-step log of the virtual packet's journey and pinpoint the exact resource and configuration that caused the connection to fail. Connectivity tests, the power of automation. The true power of connectivity tests is unlocked when you move beyond manual, ad hoc testing and integrate it into your automated processes. Because the tests can be fully managed via the command line, they are perfect for inclusion in a continuous integration and continuous deployment or CI/CD, pipeline. Imagine a pipeline that deploys network infrastructure using a tool like Terraform. As a final step in that pipeline, after the infrastructure changes have been applied, you can script a series of critical connectivity tests. These tests would validate that your core application tiers can still communicate, that your connection to a critical database is still open, and that your on-premises link is still reachable. If any of these automated tests fail, the pipeline can immediately halt the deployment or even trigger an automatic rollback of the change. This creates a powerful safety net, preventing a faulty network misconfiguration from ever reaching your production environment. Pillar 3. Performance Dashboard. The Performance Dashboard shifts our focus from network configuration and static analysis to real-world, real-time network performance. This tool is fundamentally different from connectivity tests because it measures the actual performance of real traffic, not just whether a path is configured correctly. It provides continuous visibility into two of the most critical network health metrics: latency and packet loss. Latency, measured as round-trip time, tells you how long it takes for a packet to travel from a source to a destination and back. Packet loss tells you what percentage of packets are being dropped along that path. Google automatically gathers this data using its vast, sophisticated global network fabric. Performance Dashboard. Project versus Global View. The dashboard provides this performance data through two distinct and valuable views. The first is the project-specific view, which is sometimes called the Google Cloud to Google Cloud view. This view shows you the performance metrics exclusively between the GCP regions where you have active VM instances running. This is extremely useful for monitoring the health of your distributed applications and ensuring that your application's components can communicate with each other efficiently. The second, and perhaps more unique, view is the Global View, or the Internet to Google Cloud view. This shows performance metrics not just between all Google Cloud regions, but also between those regions and thousands of Internet endpoints around the world. This global data is invaluable during the initial design and planning phase of a project. You can use it to make data-driven decisions about which GCP regions to deploy your services in to provide the lowest possible latency for your target user base, wherever they may be. Pillar 4. Firewall Insights. Taming Complexity. The fourth pillar, Firewall Insights, is a security-focused tool designed to help you understand, audit, and optimize your virtual private cloud firewall rules. In any large organization, firewall rule sets inevitably become bloated and complex over time. This phenomenon, often called rule rot, can lead to serious security gaps, redundant configurations, and an unnecessarily large attack surface. Firewall Insights addresses this problem by using machine learning and sophisticated configuration analysis to automatically examine your firewall rules and their usage patterns over time. It then generates specific, actionable insights that highlight potential risks and opportunities for simplification and hardening. Firewall Insights. Key detections. Firewall Insights can detect several critical types of misconfigurations. First, it identifies shadowed rules. A shadowed rule is one that can never be triggered because a different rule with a higher priority will always intercept its intended traffic. These create a false sense of security and should be removed. Second, it flags overly permissive rules. These are rules that have dangerously large IP source ranges, like the entire internet, or that open up a huge number of ports when only one or two are needed. The tool recommends ways to restrict these rules to a least privilege configuration. It can also show you deny rules that are actively getting hit, which could indicate misconfigured clients or even malicious scanning activity. Finally, by analyzing traffic logs, it can identify allow rules that haven't been used in a long time, making them safe candidates for removal to simplify your rule set. Enabling Firewall Insights via gcloud. Just like many other advanced services in Google Cloud, Firewall Insights is built upon an underlying API that must be explicitly enabled for your project before it can begin its analysis. While most of your interaction with the insights it generates will likely happen in the user-friendly Cloud Console, The initial setup can be easily scripted using the gcloud services enable command. This is the universal gcloud command used for activating any Google Cloud Service API. By running the command shown on the slide, you're telling Google Cloud to activate the firewallinsights.googleapis.com API for your current project. Once this one-time command is run, the service will begin to observe your firewall rule configurations and network traffic logs. It may take up to 48 hours for the first set of actionable insights to appear, as the system needs time to gather enough data to make meaningful and accurate recommendations. The unified vision, a continuous loop. The true power of Network Intelligence Center comes from how the four pillars work together to form a complete, continuous operational loop. They are not just four separate tools. They are an integrated suite designed to be used in concert. For example, your operational workflow might start in the performance dashboard, where you notice an unusual spike in latency between two regions. You could then pivot to network topology to visualize all the resources and paths between those two regions. If a specific VPN tunnel looks suspicious, you can then use a connectivity test to validate its configuration and ensure the proper routes and firewall rules are in place. Finally, if you need to modify a firewall rule to fix the issue, you can consult Firewall Insights to ensure your change doesn't inadvertently create a new security risk. This seamless flow between visualization, validation, measurement, and security optimization is what makes the suite so effective. Summary and final takeaway. We have taken a detailed journey through the four pillars of the Network Intelligence Center. We've explored how network topology provides a living blueprint of your infrastructure, how connectivity tests acts as your on-demand network detective, how the performance dashboard gives you a real-time pulse on network health, and how Firewall Insights helps you maintain a hardened and efficient security posture. By leveraging this powerful suite, you empower your teams to move beyond simply building a network. You give them the ability to comprehensively understand, manage, and secure that network throughout its entire lifecycle. This proactive approach is absolutely essential for running reliable, performant, and secure applications at scale on Google Cloud. Ultimately, Network Intelligence Center is about providing confidence and control. It is a suite of proactive tools that helps you build better cloud solutions by preventing network issues before they ever become user-facing problems. Thank you for your attendance. Please consider subscribing to the channel.